Welcome to the All Academic channel, where questions matter more than answers. Here is a strange fact about human history. Humans have existed for hundreds of thousands of years, but modern science is only a few centuries old. So what happened in between what turned human curiosity into a powerful system that can reliably discover truth? In our earlier videos, we followed the first steps. Humans learned to observe patterns in nature. They noticed seasons, stars, animals, plants, and weather. They developed tools and shared knowledge through language. Then they began to ask why, not only what. That was the birth of scientific thinking. But thinking alone is not science, because humans can create explanations that sound convincing and still be wrong. The next step was the most important one. Humans needed a way to test ideas against reality. So let's define what we mean by modern science. Modern science is a method for building reliable knowledge. It uses careful observation and measurement. It proposes explanations that can be tested. It checks those explanations with experiments or systematic evidence. And it accepts that knowledge must be revised when better evidence appears. In other words, science is designed to correct itself. Now, the big question is this: when did humans begin to build that kind of method? The story begins long before modern laboratories. It begins when knowledge becomes cumulative, when humans can store information outside the brain, when ideas can be compared across generations. Around 3200 BCE, writing emerges in Mesopotamia. Writing is more than communication. It is an external memory for society. It allows counting, accounting, measurement, and record-keeping. And record-keeping is the foundation of systematic knowledge. In the ancient world, mathematics develops as a practical tool. Land measurement, trade, construction, and calendars require calculation. And once humans can calculate, they can predict. Prediction is one of the key goals that later becomes central to science. Astronomy is also an early example of systematic observation. Civilizations repeatedly recorded the motion of the sun, moon, and planets. They built calendars to organize agriculture and social life. They improved predictions through long-term data collection. This is not yet modern science, but it shows something important. Repeated measurement can produce reliable patterns. Medical knowledge also grows through practice. Early medicine often mixed ritual, philosophy, and observation. But across cultures, healers learned from outcomes. They compared treatments. They preserved recipes and observations in texts. This again is not modern science, but it reveals a gradual shift toward evidence from experience. So why wasn't this already science? Because a huge amount of knowledge was still based on authority. If something was written in an old text, it was often treated as truth. The key missing ingredient was systematic doubt. The willingness to say, maybe the old explanation is wrong, and then to design a method to find out. Over many centuries, different regions developed traditions of scholarship and investigation. In China, long-term astronomical records and technical innovations expanded practical knowledge. In India, sophisticated mathematics supported astronomy and calculation. In Persia, scholars preserved and critiqued earlier works and advanced mathematics, optics, and astronomy. Across these traditions, we see an important pattern. Knowledge becomes more quantitative, more critical, more connected to measurement. Then, in early modern Europe, a major transformation accelerates. Roughly between the 1500s and 1700s, a new attitude spreads. Nature is no longer studied mainly through old books. Nature is studied through experiments, instruments, and measurement. This is one reason historians call this period the scientific revolution. One major change is the use of instruments. Telescopes extend vision. Microscopes reveal new worlds. Clocks and improved tools allow more precise measurement. Better measurement means better tests. And better tests mean explanations can be judged by evidence. Another major change is controlled experimentation. Instead of watching nature passively, investigators intervene. They change one thing and observe what changes. This is the logic of experiment. If you can isolate causes, you can test ideas. Another key change is the rise of mathematical description. It becomes possible to express natural patterns as equations. This is powerful because equations can predict outcomes, and predictions can be checked. If the prediction fails, the theory must change. This is a hallmark of modern scientific thinking. During this period, scientific communities also begin to form. Institutions like scientific societies appear. They encourage sharing results, debating claims, and recording methods. This matters because science is not only an individual activity, it becomes a collective system of checking and correcting. Now we reach a crucial idea. Science is not defined by being correct. Science is defined by having a method that can discover when it is wrong. That is why science advances. Over time, the modern scientific method becomes clearer. Propose a hypothesis. Design a test. Collect measurements. Analyze results. Publish methods so others can replicate or challenge, and revise conclusions when evidence demands it. This is also where modern standards gradually emerge. Repeatability, peer critique, transparency of methods, and a culture of correction. By the 1800s, science becomes professionalized, universities and laboratories expand. Disciplines like chemistry and biology develop their own methods. New tools reveal new phenomena, and science becomes closely tied to technology and industry. By the 1900s, science becomes global and collaborative. Large experiments require teams and institutions. New theories are tested with new instruments, and scientific knowledge grows at an accelerating pace. So, what is the result of this long history? Modern science becomes the most reliable method humans have for understanding nature. Not because scientists are perfect, but because the system is built to detect errors, and because it demands evidence that can be checked. This is why science shapes the modern world. It powers medicine, engineering, communication, and computing. It explains the origins of the universe and the evolution of life. And it also influences daily decisions, often without us even noticing. And this is the bridge to our next chapter. If science is a method for understanding reality, then science is also hiding inside everyday life. Inside your kitchen, inside your phone, inside the lights above your head, inside the medicine in your body. So, in our next playlist, we will explore science in everyday life, not as trivia, but as real mechanisms that shape the world around you. This closes our first chapter of the History of Science series. From observation to thinking, to method, to modern science. Thank you for watching this video. If you enjoyed it, please like the video, subscribe to the channel, and explore our other videos to continue this journey through science.